Okay, here's a calculation for the time of flight spectrometer, which first time you look at it, you think there's not enough information to be able to do the question, but there is. Okay, so they say the time of flight for the 35 chlorine isotope is, sorry, do that in a different, time of flight for the 35 isotope is that. So they want you to work out the time of flight for the 37 isotope. Now they don't tell you, well, let's see what they don't tell you. All the stuff that they normally do. They don't give you one, distance, i.e. the length of the spectrometer tube. They don't give you an accurate value for the Avogadro number. And they don't give you the kinetic energy transferred to the ions. So how are you going to do that? Well, to make life a little bit easier, I'm going to say in red, the kinetic energy that's for the 35 Cl, and in blue we'll have the kinetic energy for the 37 Cl. So we'll have all things, instead of using like these little subscripts like kinetic energy 37, which takes a bit of time to write, I'll just use color coding. Okay, so right, so now we know the equation for kinetic energy. Kinetic energy is equal to a half mv squared. Okay, so let's do that for the 35 Cl. We know that the kinetic energy is equal to a half multiplied by the molar mass of chlorine, the AR. Of course, we want the mass for one ion, not a mole of ions. So we've got to divide that by L, and then we've got to remember that we should be measuring that in kilograms, so we've got to divide it by 1,000. If we just remind ourselves over here that V is equal to distance over time, where t is the time of flight. So that means V squared is equal to distance squared over t squared. So then I've just got to do d squared over t squared, where the red t is the time of flight of the 35 chlorine. Now we can do the same for the 37, and so we know that, change to blue here. We know that the kinetic energy there is going to be half times the AR times d squared over L times 1,000 t squared, where blue t is the time of flight for the 37. Now, what do we know about the kinetic energies? Well, they're equal to each other, aren't we? So we can put those two equations together. So we get in red, we get a half AR d squared is equal to, put the 1,000 in the front, 1,000 L t squared, and that's equal to, in blue, a half AR d squared over 1,000 L t squared, where the blue t is the time of flight of that. Right, now we can cancel out a lot of stuff there, can't we? What can we cancel out? Well, the distance of the tube is the same for each one, so that d squared goes. The Avogadro constant's obviously the same, 1,000's the same, the half's the same. Right, so we get then, what's the AR in red? The AR of chlorine is equal to 35, and the AR, the blue one, is 37. So we end up with 35 over the time of flight squared for that one is equal to 37 times time of the flight for the blue one. Well, we want to find out the time of flight for the blue one, so we just do a bit of rearranging there, don't we? So we get t squared is equal to 37 over 35. Should that do 35 in red? Now this t squared is in red. It's the time for the 35. So do that in red. So put the numbers in now. The time of flight squared for the 37 is equal to 37 over 35. Won't worry about the colors. Multiplied by, now what is the, actually I'll do that in black. No, sorry. 37 over 35. What was t for the, what was this red t? Look at the start of the question. What did it say it was? I'll reduce it. It said it was 1.89 times 10 to the minus 6. Okay, so we want 1.89 times 10 to the minus 6 squared. So t squared is equal to right, so t squared is 3.776 times 10 to the minus 12 seconds. And so we to do that, so the time of flight for the 37 is the square root of that, which is equal to 1.94 times 10 to the minus 6 seconds. A quick common sense check. Well, it was for the 35. It was 1.89 times 10 to the minus 6 seconds. It should be a bit high, shouldn't it? Because the 37 is a bit heavier, so it goes a bit slower. It's the same order of magnitude, so everything looks just about all right there. Okay, so that is a good way of doing things when you think you haven't got enough information and you have. Okay, so we'll leave that there.